All right, example 7. We are going to evaluate the limit as x goes to pi over 2 of this expression here. So this expression here looks very similar to this expression in theorem 2. 1 minus the cosine of something over that same something as theta goes to 0 equals 0. But in here, while that is kind of close, and it might tempt you to go ahead and do something like, let's multiply by 2x over 2x, then we can move the 2x over here, then we can move the 3x over here, and then we can use that limit result from the theorem. That is exactly what my brain thinks very quickly. Like when I don't take time to look at it and think, my gut reaction is that. But let's not forget what we initially talked about when we first set out on learning limits, and that is always just plug in. Even if you think you know what to do, unless you're certain of what you have to do, you should always just plug in and see what you get. So let's go ahead and try that. So if we just plug this in, I'll just do this off to the side as like sort of scratch work. 1 minus the cosine of 2 times pi over 2, well that's just pi. And then 3 times pi over 2 is just 3 pi over 2. Well, cosine of pi is -1, so we would have minus -1, which would be 1 plus 1, so we'd have 2 over 3 pi over 2, which simplifies into 4 over 3 pi. But that's a real number. And there's no non-elementary functions here, and it's not a piecewise defined function. So this is actually the answer. It just so happens that this expression here, as a function, this function is continuous at pi over 2. The only location where this is not continuous is 0. When x goes to 0, this expression is not continuous at x equals 0, but it is continuous here. And we know that the limit of a continuous function is just direct substitution. So the answer to this limit is, in fact, 4 over 3 pi. So the lesson here is, although it might look like something we've seen, and we think we know what the solution should be, and we start whipping out all this algebra and start trying to manipulate things and move things around, rearrange terms, that would all be in vain in this case. And it may very well shoot us in the foot, because maybe in the process of doing all this algebraic manipulation, we end up making a mistake. So be careful there. Don't forget your bread and butter, and that is just plug in and see what you get.